Whether you're vegetarian or a die-hard carnivore, you're probably consuming soybeans in some form. Soy sauce, tofu, soy milk, naturally all come from soybeans. The issue is that 90% of the soybeans now grown are genetically modified. How does this impact our health? That's what we're going to be exploring today on Vital Science. A healthy body, mind, and soul are vital ingredients to a happy life. So let's get healthy. I'm Brendan Fallon. Remember to click that like button and subscribe to the channel. That way you won't miss future episodes. To put it bluntly, taking the genes from two different organisms and sticking them together is equivalent to making a new species. That said, this isn't really such a new phenomenon. Before genetic modification, there was hybridization and selective breeding, which is technically also changing the genetic traits of an organism like a plant. To be specific, what I'm talking about today is the modern technique of genetic recombination, also called DNA recombination. This is taking genes from one or more organisms to put them into another organism to create a new species. And yes, you're right, this is kind of what they did with dinosaur DNA in Jurassic Park. And we all know how horribly wrong that went.
Alan.
Genetic modification is all fun and games till you wake up mid-flight to a talking velociraptor. But maybe that's a topic for a later time. Today we're here to talk about food that's genetically modified. And I know there are many out there asking, why genetically modify food? So let me offer you the official rationale on that. There are three main reasons often put forward. The first is to increase production. Certainly there are parts of the world plagued by food shortage. It's said that 820 million people can't get the food they need. So upping food production through genetic modification seems an obvious solution. Reason two for using genetic modification is to make crops more nutritious. Genetic modification can improve the nutritional composition of crops. For plants, it can raise the protein, vitamin, and trace metal element contents, for example. The third and most commonly given reason for genetic modification is to increase plants' resistance to herbicides and pesticides. I'm sure those gardeners among you know the heartache of injuring one of your plant babies in the war against weeds and pests. The more herbicides and pesticides used, the more chance of damaging plant or crop health. So why not genetically build a stronger crop that's untouched by herbicides and pesticides? What could possibly go wrong?
You know the kind of eats the kind of red hot treats, the kind of sticky licky sweets I crave. Wow!
Anyway, jokes aside, these three arguments for GMOs sound reasonable enough. So why all the controversy? Well, in answer to these core reasons for GMO, there are three strong counter-arguments against them. For starters, agricultural experts say genetic modification is not the only way to increase crop yields. With good soil, good breeding methods, and better herbicides and pesticides, yields can also be increased. The second argument for GMO that's being contested is the claim that it can make crops more nutritious. Well, again, there are many ways to achieve this that don't involve genetic modification. At the same time, raising nutrient levels in plants can lead to people having more allergic reactions. For example, soybeans contain the amino acid methionine. When there's too much of it, it can trigger people's allergies. So raising nutrient levels through genetic modification or other means is not without its problems. Thirdly, there's the pro-GMO argument for making plants more resistant to herbicides and pesticides. In the case of GMO soybeans, they'd say, with this more robust plant, less herbicides and pesticides are needed at planting time. This equals less risk to the plant and therefore less risk to humans. However, the no-GMO camp says this just makes new species of pests and weeds that existing herbicides and pesticides cannot control. As it happens, GM farms show no major reduction in the use of herbicides and pesticides, studies have shown. So in theory, GMO equals less herbicides and pesticides, but in reality, that isn't quite how it's playing out. You might say the jury is still out on whether GM makes practical sense or not, but is it dangerous to human health? So far, there appears to be no long-term impact on people. A number of studies have tested GMO soybeans on animals, like mice. For one, the testicular development of mice seems unaffected by GMO soybean diet. But that's talking about mice, not people, and the particular study only ran for 90 days. If human beings eat GMO for not 90 days, but 900 days, what kind of effects would we see then? Other animal studies link eating GMO foods to higher incidence of certain cancers or higher incidence of autoimmune disease. So eating GMO is not without its dangers. In any event, the debate around naturally grown food versus GMO is unlikely to end anytime soon. Philosophically speaking, one relies largely on Mother Nature to do her thing. The other relies more on science. It's reminiscent of the debate around natural immunity versus vaccination. But that's a story for another time. I'm Brendan Fallon, and this is Vital Science. See you next time.